All right, my 8th grade friends. So here we go again. Solving linear systems by using substitution. So let's figure out what we want to do. I'm thinking that when I look at this one, x plus y equals 0, x minus 2y equals 6, that what I want to do is I want to isolate that x right there. Remember when we do the substitution method, we are isolating either x or y and then plugging the value into the other equation. So to isolate x, I'm going to move this negative 2y over to here, and that tells me that this becomes x equals 2y plus 6. Because when I bring this 2y over here, it then becomes positive. So now I want to go and plug in this 2y plus 6 into this equation, because it says x equals 2y plus 6. So for x, I'm going to put in 2y plus 6, and then it's going to be plus y. 2y plus 6 takes care of x, because x equals 2y plus 6. And then it's going to be plus y equals 0. All right, because that's what that, let's get that chord out of the way, because it says it equals 0. So to review that again, I isolated x here. I brought the negative 2y over here. That made it a positive 2y. That leaves me with x equals 2y plus 6. I now take this, and since x equals 2y plus 6, I plug in 2y plus 6 for this x right here. That leaves me then with 2y plus 6 plus y. I put that plus y equals 0 equals 0. I now have to combine like terms. 2y plus y make 3y, because there's a 1 there. 3y plus 6 equals 0. I'm going to subtract 6 from both sides, so that's going to tell me that 3y equals negative 6. And if 3y equals negative 6 divided by 3, y equals negative 2. I now have to go back into the original equations and plug in y equals negative 2. So I'm going to go to this first equation, and it's going to say x plus negative 2, because y equals negative 2. So instead of x plus negative 2, I'm just going to put x minus 2 equals 0. And if x minus 2 equals 0, x has to equal 2. Makes sense? Add 2 to both sides. 0 plus 2 is 2. It's 2 minus 2 that equals 0. That means my intersecting point, because remember, that's what I'm doing. When I solve a system of linear equations, it's 2 lines, 2, 1, 2, and I'm finding the intersection point, which in this case is 2, negative 2. All right, we got 2 more examples we're going to look at. And the first one is 5x plus 4y equals 32. 9x minus y equals 33. Well, the first thing I'm going to do is I'm going to isolate this negative y. This is the only place where I have x or y by itself, so it looks like I'm going to be working with 9x minus y equals 33. I'm going to think about this as negative y equals, and I'm going to bring this 9x over to this side. That's going to make it a negative 9x plus 33. But I don't want negative y, I want positive y. So I'm going to multiply this whole thing by negative 1. And that's going to change the signs. So it's going to become y equals 9x minus 33. As I'm going to I lost my train of thought. Multiply everything by negative 1, isolating y. Negative 1 times negative y is y. Negative 9 times 1 is positive 9. Negative 1 times positive 33 is negative 33. So now I'm going to take this y equals 9x minus 33, and I'm going to plug it in up here for this one right here. Okay? Or, okay, yeah, I'm just going to take this 9x minus 33 and plug it into this y right here. So that's going to leave me with 5x plus 4y. Y is 9x minus 33. So in my parentheses, we're going to have 9x minus 33. And it says it equals 32. Equals 32. All right, so now I'm here at 5x plus 4 times 9x minus 33. 4 times 9x, that's 36, so it's going to be 5x plus 36x, then minus 4 times a negative 33. Punch that into your calculator. You're going to get minus 132 equals 32. Now that's interesting. Okay, so 5x plus 36x, when I add 5 and 36, that gives me 41x. 41x minus 132 equals 32. I'm going to add 132 to both sides. That's going to give me 0. And I'm going to end up with 164. Okay, so now I end up with 41x equals 164. Well, to solve for x, it's just 164 divided by 41. If you punch that into your calculator, you're going to find, once again, 8th grade, it's amazing how the numbers always work out. X equals 4. All right, so, well, all right, let's see what we're looking at here. X plus 4, well, here y is isolated, so I think I'm just going to take x and plug it into this equation here. Since x equals 4, I'm going to think 9 times 4. 9 times 4 is 36. And so 36 minus y equals 33. All right, well, if I do this here, I'm thinking, well, 36 minus what would equal 33? Well, it would make sense to say that y would equal 3, because sure enough, 36 minus 3 equals 33. My intersecting point is 4, 3. All right, we're going to erase this. We're going to look at one more, and we're going to call it a day here for part 2 of the substitution method of solving systems of linear equations. But let's try this one. 6x plus y equals 4. X minus 4y equals 19. All right, let's see what we want to do. I'm going to go ahead, and this time I'm going to isolate the y. So I'm going to keep this y by itself. There's really not a bad option. I could either work with this y or work with this x. I'm going to choose to work with this y this time. I'm going to bring this 6x over here and make it a negative 6x. And that's going to leave me with y equals negative 6x plus 4. All right? So then I'm going to go to this equation, and I'm going to end up with x minus 4. And I know what y equals, so it's 4 times y. Y is negative 6x plus 4. So in this parentheses, I need to have negative 6x plus 4. And I know that that whole thing equals 19. So now I need to clear the parentheses. X minus 4 times a negative 6x is a negative 24. I know when I'm subtracting a negative, it's the same as adding. So I'm going to make that a plus. I'm going to make this 24x. Okay? Negative 4 times a positive 4 is going to be a negative 16 equals 19. All right? Now I'm going to combine like terms. X plus 24x makes 25x. We don't ever put the 1 there, but we know that's a 1. Minus 16 equals 19. All right, well, I'm going to add 16 to both sides. That's going to give me 0. I'm going to add 16 to both sides. That's going to give me 35. All right, and so then that's going to be 25x equals 35. So basically, I'm now left with x equals 35 divided by 25. X equals 35 divided by 25. And if I simplify that, both of those can be divided by 5. X equals 7 over 5. You may have figured out with a decimal that x can also be 1.4. So really either one of those is okay. I always like fractions, but depending on the situation, sometimes it's easier to work with a decimal that is terminated. So we know that x is 1.4. All right, so, or 7 over 5. So let's take this idea of x equals 1.4 and plug it into this equation right here. Because here's y is isolated, and now that's what we're trying to figure out. So that's kind of what we want to do. All right, and in fact, we can come over to this equation that's already with y isolated and in slope-intercept form and plug in our 1.4 for x. If you plug 1.4 for x into your calculator and multiply it by -6, you're going to find that y equals -8.4 plus 4. Well, if y equals -8.4 plus 4, then y equals -4.4. Your intersection point, 1.4, -4.4. All right, 8th grade. Have a great day. We'll talk to you later. Bye.